In this example, we want to solve the following exponential equation. 9 raised to the x minus 6 power is equal to 1/3 raised to the 2x power. First, you want to notice that the left side has a base of 9 and the right side has a base of 1/3. So the bases are different. And our goal is to make this equation so that the bases are the same. So I'm going to start by rewriting 9. I know that 9 is 3 raised to the 2nd power. So I'll rewrite 9 as 3 squared. And then we know that is all being raised still to the x minus 6 power. So now on the left side, I have a base of 3. So moving to the right side, it would be great for us to change 1/3 into a base of 3 as well, because we'd like to have the bases be the same. Now remember, when you have x raised to the power of -1, that's the same as 1 over x. So if you're essentially given a fraction, 1 over x, and you want to rewrite that without a fraction, that would be then equivalent to x to the -1st. You can take that denominator, bring it up to the numerator, and then that means it has a -1 power. So we can do that with 1/3. 1/3 could be rewritten as 3 to the -1st power, using that property of exponents. And then that's being raised to the -2x power. So now this looks great because we're starting to see that we have the same base on each side of the equation. But now we've got to remember what happens when you have a power raised to another power, because on both sides of the equation, we have a power raised to a power. And that's another property of exponents that says if you have x raised to the power of a, and then that's being raised to the power of b, that you multiply those exponents. So that's going to be x raised to the power of a times b. So we need to multiply our exponents here. So that's going to be 3 raised to the 2 times x minus 6 power is equal to 3 raised to the -1 times 2x power. I'll go ahead and write that as just -2x. And you could distribute. I know some of you probably already did that in the previous step, which is great. And now we have common bases. The base on the left and the base on the right are equal. And this is called using the uniqueness property, also sometimes called the equivalence property, that basically says if the bases are the same, then the exponents must be equal. Oops, I caught myself. I copied a negative there that I didn't need. Let me fix that. So on the left, we have 2x minus 12 is equal to -2x, and we can just solve from here. So if you subtract 2x from both sides, we'll end up with -12 is equal to -4x, and then divide by -4 will give us that x is equal to +3. So my solution set, if you want to write your answer as a solution set with curly brackets, would just be 3.